Good morning. I hope you can see the screen. Sorry. Wait a minute. Okay, good morning. And now I think you can see the screen. Well, thank you, Ilse, and first of all, I would like to thank Oppla for inviting me to participate in this webinar. I will present you some results of a study that we are conducting in the Balearic Islands to illustrate the importance of the spatial distribution of ecosystem services, and in particularly in the Balearic Islands. This is the study I will present. It's part of the European project Operas, and I conducted together with my colleagues Carlos Duarte, Inés Masarrasa, Jordi García Orellana, Pere Masqué, Ana Ruiz, Julia Santana, and Stefan Gelsic. Well, seagrass meadows are important carbon sinks that are declining globally. Globally, seagrass meadows are estimated to sequester about 50% of the carbon that is buried in the ocean.
Sorry, can I just interrupt you for a moment? We are seeing your presentation screen at the moment, so if you'd like to just share your screen outside of presenter mode, and then we'll all be able to enjoy your slides more fully. Thank you.
Oh, so again? Oh, okay. No. And now?
Yes, that's perfect now, Nuria. Thank you.
Yes, okay, I'm sorry. Sorry for that. Okay, so I'm sorry. So again, seagrass meadows are important carbon sinks and they are declining globally. And yes, seagrass meadows globally are estimated to sequester 50% of the carbon buried in the ocean. And also this ecosystem ranks among the ones on Earth declining at the faster rates. So there is rising interest for seagrass conservation as pathways to mitigate CO2 emissions, and strategies termed blue carbon strategies are being developed. So in the I cannot move. Okay, here, sorry. So in the Balearic Islands, Posidonia oceanica occupies a large extension of the coastal area. It extends over 633 kilometers square. It is the main coastal ecosystem in the region, and it extends between almost 0 meters depth down to 45 meters depth. As coastal ecosystems, seagrass meadows are exposed to pressures derived from human activity. In the Balearic Islands, human population has rapidly grown since mid of last century. For the last 60 years, the resident population has almost tripled, and also the Balearic Islands have become an important tourist destination, with tourist arrivals increasing from few hundred thousands to almost 16 million. That is the amount of tourists that are visiting the islands nowadays. This human population mostly is distributed along the coast. So, as a consequence, the pressures along the coast have increased substantially, and in this map shows the distribution of coastal pressures along the Mallorca coast. Mechanical damage due to anchoring and coastal constructions and coastal eutrophication are the main causes of seagrass decline in the Mediterranean, and these are also among the most important threats that we face in the Balearic Islands for seagrass meadows. In this map also it's shown the areas that are marine reserves that are indicated in dashed polygons. So in the Balearic Islands, about 23% of interior waters are currently protected, but despite these conservation measures that are implemented, they are insufficient to prevent seagrass deterioration. So in the Oppla Balearic Island case study that it's called Co-Beneficiary Management of Blue Carbon Ecosystems, we are assessing the magnitude of seagrass carbon sinks as well as the risk of carbon emissions from these sinks when they are disturbed. We measured carbon stocks in sediment cores collected at 11 meadows along the Balearic Islands. In contrast to forest, where most of the carbon stock is in above ground biomass, seagrasses store most of the carbon in the soil. And this carbon that is buried in the seagrass soil, it is provided by seagrass material, but also by alloctonous sources like phytoplankton or carbon inputs from the terrestrial areas. Well, this study, what indicates is that on average, the seagrass meadows in the Balearic Islands store about 60 megagrams of carbon per hectare, or about 220 megagrams of CO2 equivalent per hectare. And this carbon is stored within the top 30 centimeters of soil. Considering the area extent of the ecosystem, in the Balearic region, we have 4 teragrams of carbon, or about 14 teragrams of CO2 equivalent, stored within the top centimeters of soil of the seagrass meadows. The carbon that is stored in these top 30 centimeters of soil has been accumulated over between 160 and more than 400 years. However, the seagrass deposits can be thicker than 30 centimeters. And for instance, in one of the studied locations, that is in Formentera, here in Formentera Island, the carbon deposits occupy about the top 3 meters of soil that is shown in the picture above. And it has been estimated that was accumulated, it has been accumulating since 3,000 years ago. However, the magnitude of the carbon, what we are seeing is that the magnitude of the carbon deposits in seagrass meadows vary spatially, that it's indicated with these different colors. Meadows like this one here in the north of Mallorca, they have more than 100 megagrams per hectare in the top 30 centimeters of soil, whereas others, like this one here, that is in a national park, have almost 6 times less of carbon. We have also estimated that currently annual carbon sequestration per unit of area in the Balearic Island seagrass meadows, on average, it's 0.5 megagrams of carbon per hectare, or they are sequestering about 1.4 megagrams of CO2 equivalent per area per year. This indicates that in the Balearic region, the seagrasses are annually sequestering 24 gigagrams of carbon, or about almost 90 gigagrams of CO2 equivalent. Again, seagrass carbon sequestration is especially variable, with rates differing for about 3 times. In the map, again, the different colors indicates the different carbon sequestration rates in seagrass meadows, and it ranges from less than 2 megagrams per hectare per year, in this one here, up to more than 0.6 megagrams of carbon per hectare per year. So there are very few reports of declines of seagrass area in the Balearic Islands because they have not, not all the seagrass meadows have been mapped in different occasions, but there is one documented case that it's in the Palma Bay meadow. However, there is evidence that at least the shoot density of the seagrass meadows in the Balearic Island are experiencing some declines. The decline of the seagrass area, it's not only implying a loss of the carbon sequestration capacity, but it also enhances the risk of carbon emissions from the old carbon stored in the soil. And also, what we observe is that the remineralization rates of eroded carbon increases as more carbon rich the eroded material is. So, just now to conclude, these results highlight the importance of mapping of ecosystem services. First, mapping of ecosystem services shows the magnitude of natural capital in the region. Our results show that despite the extension of seagrass meadows in the Balearic Islands is about 3.5 times smaller than that in the, it's like 2/3 of that of the forest. Both ecosystems have a similar carbon sink capacity. Also, this study indicates that mapping of ecosystem health services help identification of those areas where ecosystem services are most vulnerable to deterioration, and also where ecosystem services losses can be the largest. Therefore, knowledge about the spatial distribution of ecosystem services is pivotal to develop conservation strategies of seagrass carbon sinks for climate change mitigation, but also conservation of the co-benefits that provide seagrass meadows, like fisheries, coastal protection, and nutrient removal, for instance. Well, thank you very much.
Thank you, Nuria, for the really interesting presentation. I know that a lot of our attendees are more known with the terrestrial biome. So I was just wondering if I see your map with the spatial distributions of the ecosystem service, is there currently any overlap with, for instance, protected marine areas or specific hotspots of fisheries?
Well, it's not, not all, but for instance, some of the areas that are currently protected are, they have actually some of the largest carbon storage in the region. So yeah, some of them do overlap, but the protected areas were not, they were designed basically for fisheries, but not for carbon. But yeah, some of them overlap.
Okay, thank you. Thank you very much, and I think we'll now go on to its presentation of Sander.
Hello, can anybody hear me? Okay, I'll show my screen like this. So, good morning or noon, everybody. I will try to give an overview in 10 minutes about some mapping aspects for the local ecosystem service assessment in Flanders. Flanders is the northern region of Belgium. In 2014-2015, regional ecosystem service assessment was conducted. It was quite a big and thorough process in which 16 ecosystem services were assessed and mapped. Now I will not go into detail on every technical aspect of this mapping because 10 minutes is too short for that, but I will have some reflections looking back on some mapping aspects and the use of mapping and how we could maybe improve that in a future assessment or maybe in other assessments on regional or local scales. You can find the synthesis of the assessment on the website which is indicated here and also the key messages of the different chapters. So some words about the process of the assessment. This started in 2012 with the first scoping documents and it ended in the beginning of 2015 with the delivery of these assessments to the Minister of Environment. And the whole assessment was conducted by the Institute of Nature and Forest Research, but in close cooperation with a lot of researchers, citizens, decision makers from different sectors and administrations, because of course as a Nature and Forest Institute we do not have all the access to data and knowledge and expertise for ecosystem service like food production and water production and so on. So a lot of people were involved in this assessment. And this assessment is a first stage of 3 steps. The first step being the state and trends, which I'm talking about now. The current step is the policy implementation, and then there will follow a scenario analysis for the region of Flanders based on this data. Okay, so the central figure or table in this first state and trends assessment is this one, which depicts the state and trend of ecosystem service in Flanders in an easily accessible and indicator-like approach, depicting the trend in demand, trend in supply, the balance between supply and demand, and the impact of the use of the service on other services for every ecosystem service. So this was in fact the result, the synthetic result of the entire assessment. And of course, there's a big role of maps to achieve this. Concerning the mapping in the Flanders regional assessment, we took 2 steps. The first step is a matrix method approach, where Benjamin will talk more about later on. We use this as a kind of exploratory phase. So more than 100 experts were asked to estimate the supply capacity of different services for different land use types. Note that supply capacity is something that is very hard to map biophysically, the capacity. And we determine statistical reliability on the survey, and this delivered 2 main informations. The first is a knowledge inventory, which experts have reliable data or have reliable information on which land uses and ecosystem services, so what are knowledge gaps. And secondly, a first land use based map of ecosystem service in Flanders. So the first one is the expertise inventory. You can see for every land use and for every ecosystem service we have a certain expertise, going from no expertise to basic to advanced. And also this is the color, so the more green, the more average advanced expertise we have. And also the number of scores, so the size of the dot shows the number of experts. And you can see that there is a lot of services where we have a lot of experts, but only few have advanced knowledge. And also there is quite some land uses and ecosystem services where we don't have so much experts. So this first analysis was used to filter out the scores. And if we filter out the scores and we take only the advanced, so on at minimum advanced expertise, this is the reliable data we could obtain on land use based scoring on ecosystem services. And you still see that there is a high variability. So the number of experts and their expertise varies concerning land use and ecosystem services. I think the lowest number of reliable experts for a certain cell was 7, which is still quite reasonable. This is the final result, so you can see for every land use, you can see the supply capacity for every ecosystem service. The bigger the dot, the higher the supply capacity, and the darker the dot, the higher the reliability, so the lower the range in differences between different expert scores. This information is really useful to start an assessment, and you can of course also make maps with that. And we did make maps with that, but this is mainly exploratory, as this map, of course, you cannot show the reliability or the different number of experts for every service. This is just like a static picture of what would it look like if we project this on a map, which is the general approach in the matrix method. Then the second step in the Flanders ecosystem assessment was using the best available data we have to map all our ecosystem services. So in total about 40 experts, so these were real like scientists, modelers, mappers were involved from the food production sector, from the water production, water retention, hydrologists, ecologists from different institutions. And supply, demand, use and different components were mapped separately using the best available data and models. And of course, since we are using all the best data, it's a bit difficult to estimate reliability, but of course the argumentative confidence of this kind of maps is quite high. These maps can be accessed on this website, so you can filter according to ecosystem, according to map type, and you can download and also check contact details and so on. So with these 27 reports, 78 maps, we thought our mission is accomplished for the European targets. We have all these maps, all the methods, we are very happy. And now I want to look back and to look at the more scientific challenges of these maps. So first of all, they are not all comparable. This is the same map for wood supply in Flanders according to the same scale. The first map shows you the biophysical potential. The second one shows the potential wood supply only in forests, so land use. And the third one only in forests where legally it's allowed to harvest wood. So this is already highly different. And if we project this over the whole bundle of maps we have, we can see that for every service and every thematic map, we have some maps, and these maps in itself, they are useful to base policy decisions on, but to aggregate them and draw general conclusions on the state of ecosystem services. And this is what we call statistically Gruyère. It's the Swiss cheese with more holes than cheese. So this is a bit of a problem. A second challenge is that we have a variable coverage due to model assumptions. Some models assume that a certain land use does not have a certain ecosystem service, like for instance urban. And this differs between the models. And if we distinguish no data and zero supply, and we project this on the map, we can see this. Again, for the separate maps, this is not such a problem, but when we want to aggregate and we want to make, for instance, accounts, land use based accounts, this is highly problematic as the total surface covered is different, and for an account this is quite essential. Third, the maps, the aggregated maps are highly sensitive to which service you include. This is just an example. I cannot go really into detail, but you can check in the publication. If you make a bundle map for provisioning services, for instance, and you include or exclude a certain service, this gives highly different results. So what did we base this table on, this assessment? We can see that there is indicators for every cell and also reliability components. So data screening of which data we actually used is this. There is a lot of qualitative data, representative data, proxy methods, non-validated models, and also a bit of validated models. And these data stretch all the different components which should be included when making a judgment on the state of ecosystem services. Concerning mapping, in fact, about 40% of these data are spatial data, means maps, and about 60% are non-spatial data. And you can see for several components of an ecosystem assessment, in fact, there is no spatial data. Governance, drivers, And for other aspects, there is a need for non-spatial data when doing making judgment on the demand and the use of ecosystem service. A lot of your data will be non-spatial. So conclusively, the idea is to set the mapping requirements depending on the goal. So if you make maps for advocacy, an ecosystem assessment, or you go all the way to highly risky or high demanding purpose like economic liability or research, the requirements will go up. The lower level of your mapping requirements is the risk. If you make a map which is not reliable enough and you apply it for a highly risky decision or a liability, then you have a risk to take wrong decisions. The upper level of your mapping requirements is parsimony. Mapping is really costly in time and resources and modeling, and if you make a map on a 1 by 1 meter resolution with the best models available, and this is just used for advocacy, this is kind of a waste of money. So we would, looking back, think more of to apply mapping as a doctor. The doctor sees a patient coming in and he judges the urgency of the problem and the use of making more expensive analysis in hospital, or seeing expert judge based, like, okay, this is a clear problem and we can do this. So the first step is to define the purpose of your mapping sharply, screen potential methods, mapping and non-mapping, estimate the costs of these methods, and check effectivity to purpose together with the end users, and only then start mapping. So the idea is to combine methods to achieve a certain purpose together with the end users, and this is, looking back, what we might do differently maybe in the assessment Flanders, to make sure that the maps we produce, all these maps, can actually be applied in a concrete policy context. Thanks. That was it.
Thank you, Sander, for the very interesting presentation. I'm really impressed with the amount of information that you can provide on the actual data and on which of the elements in ecosystem services flow you have been able to quantify. I'm wondering if you have any idea about how the different kinds of methods and their related uncertainty actually affects practitioners or decision makers in their process of either management or governance decisions.
That's a good question. Concerning the ecosystem assessment, the team is now implementing the data and conclusions in a few concrete contexts. In parallel, we are also doing research within openness on application of ecosystem service concept in different concrete real-world contexts. And this is one of the questions we are tackling, and we are wondering about ourselves: to which extent can this concept be useful? Is it used? What kind of adaptation could be made? And what is the effect of data quality, effect on uptake by end users? I don't have the answer yet, but it's one of the interesting questions we are working on also.
Okay, thank you very much, Sander, for that explication. I just want to remind the audience that you can actually place questions via the Oppla ask function or via the chat functions, and then we'll be able to pose them to the speakers, and we'll be able to come back to Sander's presentation at the end. Thank you, Sander, and I'd now like to pass the floor to Benjamin.
Hello everyone, good day. Can you hear and see, can you hear me and see my screen?
Yes, we see you and hear you, Benjamin, thank you.
Okay, very good. Thanks for inviting me. I would like to talk a little bit about mapping and assessments of ecosystems and their services in Europe, and refer a lot to what we do in the Esmeralda project since about more than 1 year now. So, what do we actually need to map and assess ecosystems and their services across different biomes, states and policies? And I'm very happy that I can talk after Sander Jacobs, because he was really preparing the floor already for these conceptual parts of the talk. So it's really needed to mobilize all the relevant actors which are involved in ecosystem service science and application so scientists, policymakers, practitioners, the business sectors, and of course also the society. Then we need some strategies, what we really want and how we do it in Europe, this mapping and assessments. And of course we need a lot of methods and data to map all these different ecosystem services on different scales and to really integrate them into interdisciplinary assessments. And then of course we need applications of these assessments across Europe, across different policies and themes to make these things that we collect, all these methods we develop, all the data we have, to make them really applicable for decision making and for improving decision making in the end. So the question is really, or the questions are, who can do it and who needs this information, when we do it and how do we do it, of course again referring to methods and data, how we do it, and then also where we do it and why we do it. And of course this why we do it is quite a relevant question. So there are many policies, if you look at European Union and European Commission's policies, and their ecosystem services are increasingly seen as an important concept that really can help to achieve targets and goals that these different policies have. And we really hope that ecosystem services can add value and can really make a difference to improve these policies. So one of the most prominent examples, for example, is the agriculture policy. There I think ecosystem services can contribute a lot, and also mapping can contribute a lot to come to a bit more sustainable and site-specific management of agricultural areas, but also the regional policies, climate change policies, fishery, forestry strategies, marine strategies, water strategies, and many, many others. So if you check this at the moment, how ecosystem services are integrated in the strategies, it's not so much yet, but we are really on the right way, and the European Union is pushing quite a lot there. I think there really ecosystem services can provide a lot. And I think now we are there that we have quite a good knowledge and data and methods base for mapping and assessment of ecosystem services. So now we really should look which policy question we can address and how we can guide these integrated assessments. So how to map and assess ecosystem services, how to carry out integrated assessments. We developed something what we call the 9 steps. And in the beginning, of course, there should always be a question from policy, from the society, or from the business sector, or a theme which should be addressed by the mapping. So don't start your mapping. Of course, you can also improve your methods, but in general, there should also be a question behind. And then it's quite simply just look which ecosystem types are involved, which are relevant for your question, for your theme, or which are also relevant for your region. Then start to map these ecosystem types. There are a lot of data available from the Korean land cover set, but also remote sensing data, national data sets, model data. And then you start to assess the conditions of these different ecosystems, look at the status of the biodiversity there, which habitats are there, which functions are important, what is the conservation status. Then you can select or should select indicators to assess and describe these conditions of the ecosystem, quantify these indicators, use different methods. Tier 1, this what Sander presented, this matrix, for example, expert-based, or Tier 2, use statistical data or monitoring data, or Tier 3, use some computer models to quantify your ecosystem conditions, and then you can finally map them once you have all this different information. It looks quite similar for the ecosystem services. First you identify which ecosystem services are delivered by the ecosystem which are in question, and also in your region you can use the CITES system to identify them. It's a kind of checklist. Then you select the indicators to assess the supply, the flow, and the demand for and of ecosystem services. Then you quantify them using different methods. It's good to integrate methods from biophysical sciences, from social sciences and economic sciences. Again, these different tiers can be combined or should be combined in this assessment, and then you can also start to create your map and present your indicator data in a spatial way. And then of course it's needed to integrate all this information from the different parts of your assessment, check which interactions are there between ecosystem conditions and ecosystem services, what ecosystem trade-offs or synergies between the ecosystem services you can identify, and of course what are the consequences for human well-being. And then once you have these results integrated, you have to communicate them in a way that is understandable for your audience, for the policy and the society and decision makers, also business related, and you have to appropriately disseminate your results. So this is the whole, it's a little bit linear of course, but this is quite the way how you can carry out such assessments, and of course it's very important to involve the stakeholders. in an optimum case, of course, in all steps, but in most projects, this should at least be done by the identification of the topic, but also by the ecosystem type identification and the ecosystem services. And of course, finally, when you integrate and apply the results and communicate your results, you definitely have to involve stakeholders. What we do in Esmeralda, it's a Horizon 2020 coordination and support action that aims to support the European Union member states in the mapping and assessment of ecosystems and the services. It started last year in February and will run a bit more than 2 years. And in this project we have different phases. The first phase was actually dedicated to identify who are the stakeholders and which are the relevant projects and databases. For example, Oppla, such a relevant database and project for mapping and assessment in Europe, and to create links to them. And then we were identifying which are the gaps in the different member states, why there are problems or where there are problems to map and assess ecosystem services, and then we try to give some recommendations to overcome them. And it was quite interesting that one key problem in most member states is the lacking engagement of national authorities in the MAS process. So many ask, why should we do this? What is the value added? How can we perform this? There's an unsatisfying stakeholder involvement in many European Union member states, and there are also some gaps in capacity and resources to carry out these activities on a national level in these different EU member states. We developed some selected recommendations by this. One very important point is the justification of this whole mapping process, and there it would be very good to have some good case examples where we really can say, in this case, ecosystem services and their mapping helped to improve the decision making, they led to a more sustainable situation and really helped decision makers to find smarter solutions. In these cases, there are a few, but not too many yet, but I think as soon as they are there, then also there will be kind of effect that many countries and decision makers will go for this concept. But this is still really needed at the moment. We need better communication of these complex scientific findings dedicated to certain target groups. We need capacity building, educate experts that can do these kind of complex assessments, technical support, of course, how to use the data. We are about to develop some guidance how to map and assess ecosystem services, and of course also really work together, network and use what's around there and harness the knowledge and the data that are there, which is not so little actually. You can read more about this in our Esmeralda deliverable, which you can download from the website, where this is documented also more detailed for the different member states. And you can also go to the BISE website, the Biodiversity Information System of the European Union, and there you find a lot of information about the different member states, how these MAS activities are developed in the EU, and perhaps this will also soon be available via Oppla, I think. Then the phase where we are now is review which existing ecosystem service mapping and assessments are there. So we are about to review 300 scientific articles, studies which were done in the European Union and also own works. We check which methods are there. We check which different tiers have been applied on different scales. And based on this, then we want to develop guidance how to map ecosystem services. So if you have ecosystem service A in ecosystem type B on scale C, then you have these different methods available, and they have been applied and showed good results in this study. And this is what we are about now. And then we want to test this in different case studies across European Union member states, cover quite some varieties about natural and socio-economic conditions, and also different EU policies we would like to address with these case studies. And then we collect some feedback from stakeholders to improve the methods, and then eventually produce these flexible solutions, as we call them, for ecosystem service mapping and assessment, applicable for decision making. And one important point really seems to be to develop these guidance documents on how to map ecosystem services using different methods, different data, and different ecosystems on different scales. And then finally, we want to implement this project results in the context of the biodiversity strategy and develop long-term implementation beyond Esmeralda for mapping and assessment of ecosystem services. But of course, this is quite a tricky point, how to implement ecosystem services. Scientists, they like them quite a lot. Ecosystem services, they think this is a good concept, it helps us, but also most scientists are used to think in quite complex pathways. and they are used to deal with dynamics which are difficult to determine, and they are able to deal with complex human environmental system, but the scientist also wants absolute certainty before she or he is publishing the results, so that many results, they really just stay somewhere hidden in offices and are not really used. On the other side, you may have the politician or the decision maker or the business persons who would like to apply this, and they usually prefer reduced complexity. They do not have much time to read. They want highly aggregated information, in the best case indicator value with one number, and they want, of course, information that is relevant for specific problems and in support of his or her policy program, and they want it all very quick. And of course, you can imagine there's a certain gap between these different demands and ideas that scientists and users of ecosystem service maps have, and this is really needed to bridge this, and both sides have to come together and to cooperate, and scientists really have to tell what they're able to deliver, and the users should tell the scientists what they really need and what's useful for them. And I think there's still quite a lot of gap, and this is what Sander Jacobs once called this urgency-uncertainty dilemma in ecosystem service decision support, that policymakers have urgent problems, want quick solutions, and the scientist doesn't feel very comfortable to deliver uncertain information or uncertain maps. But I think we work on this, and a lot of things have happened in the last decade, and I think also this is quite in a good way, but of course we really should support this. And with this, I would like to close and thank a lot for your attention.
Thank you, Benjamin, for that presentation. I can see that Esmeralda has quite high ambitions. I think a lot of us are struggling or applying ecosystem services assessments at regional or local scale, and we already encounter a lot of problems. So I can imagine that doing it at European scale increases that complexity even further. Just leaping ahead, though, the results from Esmeralda and the European mapping effort obviously provides information for European purposes, but there are also global purposes where that information might be very useful, like the progress on the Aichi targets or the IPBES regional assessments. Have you looked at the potential methodological issues that you might run into when you try to transfer the information at European scale to that global scale?
A bit, but not too much, because at the moment we are mainly busy to transfer results from regional scale studies. Because if you check where ecosystem service mapping has been carried out, about 70% of the studies were on a regional scale. And now we try to, so to say, upscale this regional scale information and the methods to the national scales of the countries. This is a key target of Mars and the biodiversity strategy, actually. Then perhaps in the next step, integrate this into European maps, and then perhaps go to the global scale. And of course, the methods we develop, they are applicable in many different regions, but the global scale is not the key focus of the European Union project at the moment.
So there is still quite a lot of way to go before we can actually participate fully in that debate.
Absolutely, yeah.
Thank you very much, Benjamin. I'm just going to go through some of the questions that have come in to the chat function. For instance, Miria, we have a question from Garciela Rush about what the main direct drivers are of change of seagrass cover.
So in the Mediterranean seagrasses, but also it applies globally, the main drivers that have been attributed to the declines of seagrasses observed are eutrophication, so enrichment of the, well, it's an increase of nutrient and organic load to the coastal waters, and also physical impact like coastal works, or in some areas bottom trawling or coastal erosion. And also since last decade, there are also increasing the reports of loss of seagrass due to global warming, and this is an issue in the Mediterranean Sea.
Okay. Thank you very much, Nuria. I have a question to Sander from Liliana Solfigueras. You said that you're working on how different methods influence decision making, but are you working also on how uncertainty related to ecosystem services affects decision making?
Well, that's a bit the same question that you asked me.
But those are methods.
We don't know yet.
Oh, you don't know?
Yeah. Well, the thing is that, of course, there will be an influence of uncertainty on the decisions, because if you take a decision based on uncertain data, this increases the risk for undesired outcomes. So any uncertainty translates into risk. However, it's not so clear yet how decision makers are influenced by uncertainty. Often uncertainty is a bit of an inconvenient issue. Like they prefer just really certain data, and if there is uncertainty, it doesn't need to be shown too clearly. I don't know. This is a real interesting topic to check. It depends on the amount of responsibility, behavior, and risk-averse behavior of the policymaker or decision maker, and also on the actual societal risk involved. That's the only general thing I could say.
I think there must also be some experience with indications of uncertainty and the impact on decision makers with the CBD reporting. So the global outlook also includes statements on how uncertain the results presented actually are. But it's true that's not on ecosystem services.
There's a bit of a trade-off. If you stress the uncertainty, the conclusions might be discarded as a whole by people who could be affected negatively by policies that are based on it. On the other hand, if you show uncertainty honestly, then this could generate more credibility for the data, which it actually has done. But also, it could be used to direct research. Because, for instance, the table that I showed with the state and trends, you can see the coloring which represents the reliability of the data we have to make this certain statement. The paler cells, which are in fact with data statement, but it's based on less data or on expert judgment, this could be the focus for further research. So it could also direct policymakers towards the urgency to invest in research on certain topics which are highly important, but where uncertainty is too high or data is lacking.
Yeah. Okay, thank you, Sander. We're taking one last question for Benjamin, and then we'll close the webinar for today. So Benjamin, I'd like to pose you a question posed by Deepa Palunikatil. I hope I pronounced the name correctly. So okay, land use mapping helps, but he would like to know if a map of provisioning services such as wildlife foods, which are not static, how can you map those?
That's a tricky one. Also, if you want to make it more dynamic, you can use time series of maps, but this will maybe not help you so much with the land use. If the land use forest, for example, where this wildlife food is a lot, is there, then you have to integrate further data, of course, to make it more dynamic. You have to go there to the area to check what's there, how it's developed, how people get out, but especially this wild food is a really tricky one because there are no real data available because it's so privately owned. So you always will have to use some surrogate information like land use data and then get some information, but that's a really tricky one.
Okay, thank you, Benjamin. There's quite a lot of questions now coming in, which we will be sending on to the presenters and ask them to reply to, and then we'll put them on Oppla. So I'd just like to show you where you can actually find your questions and where you can also contribute to questions posed by the other people from the audience. So this is the Oppla site, and you have to be a member of the Oppla community, which most of you have now done. If you go to the Ask Oppla function, so here you can ask additional questions, also completely not related to the webinar. And then here in the bottom is the questions, and then you can see all the different kinds of questions that have been asked in the recent time. And then you can click on them and comment on them or search on specific topics that you might find interesting. Okay? So with that, I'd like to thank everyone, inclusive the presenter, who have been participating in this webinar. It's very good to see the different views on the implementation of ecosystem services. Thank the audience, everyone for their patience, having listened and contributed to this webinar with important questions. We hope you've enjoyed it and that you're keen to sign up for our next webinar in June. The exact date has not been decided upon yet, but you'll receive the information by announcements via the Oppla network, and you can also find it on the Oppla website. If you have any remaining questions regarding this webinar or ecosystem services or nature-based solutions in general, we invite you to post them on the Oppla site that I've just shown. But also, if you have suggestions for webinar topics that you would like to listen to, or maybe you would like to present on it, we'd be really happy to receive any of those suggestions via this site as well. So the Oppla site will be officially launched in September, but we're already a growing community starting to exchange ideas with over 60 universities, research institutes, agencies and businesses, and you're very welcome to join us, and all you have to do is register online. So I'd be very happy to see you at our next webinar. Thank you very much and talk to you soon.